welcome to the Injective Global Virtual Hackathon. In this video, we're going to be going over CosmWasm for beginners. So just, a real high-level overview in how to use CosmWasm, what's it all about, so on and so forth. So yeah, as described, this is going to be about CosmWasm for beginners. And in addition to these slides, where which just serve as sort of talking points for like some of the things about CosmWasm, there's also an accompanying repository with a test smart contract or a dummy smart contract that shows some of the key features of CosmWasm and how to use it. So the agenda for this presentation is we're gonna start, or it's not just a presentation actually, hopefully, it's a bit more than that, because we're going to start by answering the question of like, what is CosmWasm, a little bit of what is Rust, then how does CosmWasm work and how does it, reflect with other smart contract languages, technologies, i.e. Solidity or Solana, I guess, are the best known ones. And then in addition to that, or sort of as an accompaniment to that, we're going to get our hands dirty, and there's, as I mentioned, a dummy smart contract where we build a escrow contract with a token, and so we're going to kind of go through some of the key bits that we mention in the sort of the description of CosmWasm, and then like use them and start building a smart contract. So as I described, we have the CosmWasm 101 repo in GitHub Injective Labs /CosmWasm 101. So the first thing to do is probably pause the video, navigate to there, and then once you've found that, then come back and unpause the video. So now you've done that, I guess, maybe not, we can move on and we can start to talk about what is CosmWasm. So the first thing about CosmWasm is what is WASM, right? So WASM is WebAssembly, and it's one of the most optimized virtual machines, primarily for use on the web. And literally, CosmWasm is the WASM VM for the use on Cosmos SDK blockchains. And so, okay, maybe we just briefly, hopefully you know what Cosmos is or what the Cosmos SDK is, but the Cosmos SDK is a set of libraries that are the building blocks for building Cosmos blockchains. So the Cosmos SDK are a bunch of Lego bricks which you can plug together as you wish, and then put on top of a Tendermint consensus engine, and you have some sort of Cosmos SDK blockchain. So that's Injective, that's Osmosis, that's Juno. And all the Cosmos, or all CosmWasm does, is create transactions that are submitted and processed by the underlying Tendermint consensus engine in the Cosmos world that apply state transitions to the smart contracts. So yeah, the WASM VM is just one building block of the Cosmos SDK. So what are the key features of CosmWasm? So I'm sure many of you listen to this video, it won't be your first time thinking about smart contracts, so you might have done something like Solidity. And in Solidity, you have the interface, or you have a defined interface of your smart contract, which really is sort of the API to the smart contract. And it's kind of similar in the CosmWasm universe. We have three defined entry points, which are instantiate, execute, and query. So instantiate is kind of like the constructor in a Solidity smart contract, although it's a little bit different, which we'll go into. Then there's the execute, which are the entry points or the API parts for applying state transitions to a smart contract. And then there's query, which is kind of an optimized way of querying the storage, and obviously is read only in a CosmWasm smart contract. So, and apart from that, it's not strictly true, but apart from that, everything else is sort of standard Rust, or is just pretty much Rust, right? So that means you can use all the relevant Rust libraries, so you shouldn't use stuff that's non-deterministic, but as we go into this, we sort of, through using the CosmWasm VM, the Cosmos VM, CosmWasm virtual machine, we sort of avoid that a little bit. But another thing to mention is that all interactions, and this is true for the whole of the Cosmos SDK, so Cosmos SDK, all it does is it sends messages to the consensus engine, and they're processed and state transitions applied. And that's sort of like, that sounds a bit abstract because you're thinking it like might sound a bit abstract because we have this virtual machine, where the smart contracts are run, but it is literally the same as all the other modules of Cosmos SDK. So that's the bank, which if you have seen Osmosis through the token factory, another module, you can create new new tokens in the bank module, which are the native denomination or the native coin of a Cosmos SDK blockchain. But point being is that when you you say you have two contracts, contract A and B, and you want to do some, maybe it's an escrow, like in this scenario. We might trigger on the escrow contract. We might say, okay, blockchain A or smart contract A, do something, and then we, in Solidity, you could call to, an instance of another contract, do some more computation, which will then return and do something else. But you can't actually do that in Cosmos SDK, or not in Cosmos SDK, in CosmWasm, because all interactions are through standard messages, which means if you want to do something in smart contract A, you have to end the transaction, send the message execute the message for contract B, and then return. And so there's a way of ensuring how the flow of the returns works. But basically what this means is that there's no reentrancy by design, and reentrancy is kind of a common attack in Solidity contracts. Another sort of key difference or feature, again, just focusing on Solidity because it's the most known, but is the memory management. So in Solidity, if you define a variable in your smart contract, that has some state and can be updated. Whereas in CosmWasm, we have to define the data structures to store, and then we have to manage the storage of them ourselves. So if we have a smart contract where we have a config, so that config might be, some struct which holds an address. If we want to change that address, we first have to load and then, update that instance of the config and then save. So, it's not like, tremendously difficult or anything, but it's just a slight difference. Then, the next kind of thing to think about, and these aren't, this isn't exactly an exhaustive difference of CosmWasm against other things, but just a high level overview for those who haven't seen it before is that the contract life cycle is also different. So you write and compile code, and then once you've compiled it, so you compile the Rust to some WASM bytecode, you upload the WASM bytecode to the blockchain, and it then has a code ID. And so once you know the code ID, you can then instantiate instances of contracts. So multiple people could, if they know the code ID and how the instantiate messages should be formed, they can instantiate multiple instances of the same contract. And following that, you can execute query functions. So, it's not like that difference, but it's a small difference. Then, just to hammer home, CosmWasm is not only in Rust, but most people will write in Rust. So what the hell is this Rust stuff? So for anyone who hasn't seen or heard of Rust before, it's a modern programming language with all the proverbial bells and whistles. Libraries are typically called crates, and the package manager is called cargo. So later, when we go through the tutorial, you can see cargo. You're going, what the hell is cargo? Cargo is the package manager for Rust. The only real thing to note that people who are fairly competent programmers might not have seen before is it uses options quite a lot. So when you return the function, often you have to first do unwrapping or use the question mark, which is kind of similar to the unwrapping to get the result. And so that's because typically the option will have some or none if maybe there was an error or maybe there was no data. So you always have to kind of handle errors or handle the data okay, if there's nothing there, then we do this. If there's something there, do this. Obviously you don't have to, but when you see unwrap, for me, the first time I ever looked at it, I was like, oh my god, why what is unwrapping? So yeah, that's a very, 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 very high level overview of what is Rust. So then let's get straight to it. Let's set up the development environment. So if we go to the CosmWasm 101 directory, so if you once you've downloaded it, you can obviously navigate to it in your browser. You'll see we have in the master branch. So the way we've organized this is that we have we have this dummy thing we want to do, but like we're going to go through a number of sections from 0 to 6, and they should take us from being able to do nothing to being able to do something. So if we first either in well, let's just go here, and the first thing we're going to do is we're going to clone the code. So then if we go to our IDE and we go close all this stuff and we return to 0, so here we go. So let's check out the master branch. Oh. I was just going through this tutorial beforehand to make sure that I was saying everything correctly, but I forgot to reset this. So let's check out section 0. So just as I mentioned, so if we do git tag -l, you can see all the sections are listed. So section 0 is the first one, then 1, 2, 3, 4, 5, 6. I mean, should be fairly intuitive, but just in case people were thinking, what the hell's going on? So this is going to be the first start is getting started and setting up the development environment. So the first thing you're going to want to do, hopefully, so firstly, there's a prerequisite that this tutorial is mostly based around people using Unix systems who have a terminal. Everything is completely possible in Windows, just I don't know how to do that, so you'd have to have a look, a little bit on your own how to use Git in Windows, but I'm sure you're very capable. But the first thing to do would be to clone this repo, sort of as I've done, enter the repo, and then check out section 0, and then we'd be here. So if we type in ls, you should see something, the readme. So hopefully you can see the readme, and that should be everything done. So if you get that far, then section 0, like the sub step, has been completed, and hopefully we can begin. So now what's the next thing to do? Navigate to section 1 in order to find the instructions on the environment setup. So let's do that. Git check out section 1. Look, and so now we're going to see how can we set up the environment. So the first thing you need to do is install Rust. So if we navigate to this web page, so everyone can see, this should allow you, if you follow the instructions here, you can install Rust. So it sees that I'm running Mac OS, but it's possible to do it in Windows, Linux, whatever you want. And then next, download Rust. So this is the command for that. And if I put it in my, I already have Rust, but if you do that, what happens? Okay, so 3, I'm just going to cancel the other thing. But if you follow the instructions, it should be able to, it should install correctly. And then you need to do Rust up. So Rust up is like the management tool of the version of Rust. And then you, like I mentioned, you have Cargo, the package manager. So we should first install Rust, then install the stable branch, and then let's check the version. So if we just do cargo version, so everyone at home do cargo version, and you should get something like this. I think if you have a version that's lower, so like 1.55, then just do Rust update stable, which we should have done there. But maybe there's something happens there. And then the next step. So once we've downloaded Rust and checked that it's installed properly by doing cargo version, then we want to add the CosmWasm targets, and these are this is the first important step before we can start to develop in CosmWasm. And then the last step before, so you could just copy and paste that in your thing. I don't think I need to do this to show you how to do this, is to install Cargo Generate. And so what Cargo Generate is, if we just navigate to this this repo. So Cargo Generate is simply a tool that allows us to to use other people's pre-existing templates for things. And so, surprise, surprise, there is a CosmWasm template, and that's what we're going to use in order to set up our repo and really, get from 0 to 100 and be able to make a CosmWasm smart contract really quickly. So if we do that, then we can install this cargo run script and install cargo generate. So these are two cargo packages that we're going to use. And so once that's done, so I've already done that, but you should do that, and there shouldn't be any problems. If there are, then obviously please let us know, but or check the repo of cargo generate. But once you've done that, then everything should be, as they say, Gucci gang. And then like the last thing we should, so just going to fix this typo here, recommended IDE plugins. I mean, there is a JetBrains Rust version, whatever, IntelliJ Rust. That's not my style, my flavor, but for those who it is, they should use that. Personally, I use Visual Studio Code, and there's a really nice, I was looking at Golang stuff before, so I recommend this Rust Analyzer if it ever loads. So I use this one here, Rust Analyzer, as the extension for Rust stuff. There is like the official one, but I prefer Rust Analyzer. So, I mean, feel free to try both, but that's the one I use. So, hopefully that's all gone successfully for you. And so now let's move to the next section of getting our hands dirty. So how should we do that? So we've well, let's just recap actually. So we set up the Rust environment, we installed the CosmWasm target and cargo generate, and if you're a real connoisseur, you added the Rust analyzer to the IDE. So what are we going to do next? We're going to create a CosmWasm smart contract. And so to do that, we're going to go git tag-l, and we're going to, so I think now we're on section 1, so we're going to go git check out section 2. Git reset -- hard. Okay. You know what? Yeah, so I'd run this earlier, so I just want to remove CosmWasm. And then if I go git check out section 2, so this shouldn't happen for you because you didn't mess around with it before. So okay, so sorry, I just had to delete an untracked directory. So section 2, generating a CosmWasm contract. So as I described to you previously, in the previous section, 2 minutes ago, we installed cargo generate, and now we're going to use cargo generate to create a contract skeleton. Yeah. And so in the terminal, so if I stupidly have done this before. If we just remove the CosmWasm directory, and now we take this command. So I'm just going to clean. So here we go. And so I think if you want a proper name, this is, so we're just going to put this all to lowercase so it looks a bit better. But we're going to generate a new, so basically what this does is it follows it takes the template that's here at CosmWasm CW template, and it creates a new template under the directory CosmWasm. So you can see that here, and minimal. So this just means that you could run it without this flag, and there's a few other things that it'll ask you. But if we do minimal, then it's just it's like no extra gubbins. So if we check this repo now, you can see that there's like suddenly, I deleted it previously, but suddenly there's a lot of stuff in this repo. So what is there? So firstly, there's the README. So maybe take the time to read this. Like this actually has a lot of the same content that we just discussed. So creating a new repo from the template, blah, blah, blah. Nothing that interesting here. License and notice, the cargo.toml. So the cargo.toml is quite important because it's where a number of the packages, libraries, or crates that you're using need to be defined. So here you can see this template already has a number of the key CosmWasm libraries. So there's CosmWasm Standard, CosmWasm Storage, and this CW, which is just CosmWasm Storage Plus. These are all some of the standard dependencies that we're going to use in this project, and that are used in the template. For example, there's the multi-test library, which we're going to talk about a bit later. And then last but not least, so there's also these like .cargo, .circle, blah, blah, blah. We can just ignore those. Then we have the source directory, and in the source is where the contract is defined. So for those who've never worked with Rust before, so the live.rs, it doesn't have to be architected like this, but this is a typical way. So in the lib, you have links to, or not links, you have declared the files that are included in the project, and then a typical framework or architecture of CosmWasm is to have the entry points, which we discussed previously, defined. So here you can see instantiate, execute, and query. And if we go back to the slides, you remember I said there were three defined entry points, the three main entry points, which are instantiate, execute, and query. And lo and behold, when we look here, we can see them, but everything is unimplemented. So, all right, if we go back to the README, now we should see, now we can check if we have a directory similar to the following. So at home, do tree-l if you have tree installed, and you should see something like this. So this is where when I deleted some of the useless files, but this should be what you see. And if you don't have tree, I think it's something you can, you get the idea. You can just do ls or whatever you want to do in Windows and check that you have a directory structure that's similar to this, and that cargo generate has worked as desired. Okay, so if we come back here, we've created a CosmWasm project. So we were just creating a CosmWasm contract. We didn't really do much, but we did that using the cargo generate tool, and we took a little look at the entry points. And so now, so if we just go back to the entry points, in the next step, well, I wonder what we're going to do. We're going to actually start to build the contract. So, next step, nothing beats design. So in this step, this is a little bit personal, something that I like to do before building anything really, is to no matter how stupid the project is actually just to try and have a little design idea, and so that we build something that makes sense, or that we know what we're going to build. So if we come back here and we go check out section 3, so that's the next section. Oh wait, so get reset hard. So because I'm doing this, so boom. So now what we're going to do in this section is we're going to use plant UML to make some component and sequence diagrams. So really this might be very uninteresting to people, but I assure you when you build complicated projects like this is something that's quite important. So take the time to have a look at plant UML. It's very ugly, but basically it'll tell us how to build component diagrams, which is the first one we're going to build. I'm just going to briefly go over these. I won't spend the time of actually building them with you, but you guys can just have a look. And then sequence diagrams. And so through this, so this is another reason you're going to realize what the project is that we're going to build. So now in section 3, made for me is so you could either follow it this way and do it by scratch, or so make the directory and then create the things, and then using the plant UML documentation, create an instantiation, escrow, redemption, queries, sequence diagrams. But probably that's kind of boring. So the first thing we're going to do is look at a component diagram. So this is the component diagram. And so what we're going to have is we're going to have a token contract that we're not going to build. So it's going to be a CW20 token. So that's so maybe in a second. So that's like an ERC20 token that we're going to mint and then, can send to people. And then we're also going to create an escrow contract, and the escrow contract is the thing, the thing we're really going to build, and that's going to allow a user to send their tokens to the escrow contract with a time limit, and then redeem them once the time limit has passed. And there's also so this just shows an overview. There's also an owner of the escrow contract who is in charge of instantiating it. And so why I like Plant UML is because it's actually typed diagrams, so it's much easier to interact with, if you ask me. So like I mentioned to you, maybe token contract is kind of ambiguous, so we could rename that and we could call it CW20 contract. And then here, if we just go Plant UML, so if you learn how to install Plant UML, and then I think this will do it for you. Diagrams, and let's do the component diagram.pummel. So this will compile this code, God forbid, and output a PNG. And here you can see now we've got a CW20 contract instead of token contract, and that's probably very uninteresting for most people, but this is really something I like to do. So as we described in the README, we're going to try and create 3 different sequence diagrams. So if component diagram is like the diagram that shows the components of the project. So in this case, at this high level, just the smart contracts. Obviously, you could maybe include the blockchain, blah blah blah. The sequence diagrams, kind of the way they are technical things, but the way we use them is to describe the sequence of user stories, with the components from your component diagram. So the first one we're going to talk about is the instantiate sequence. And if you remember, whoa, this got bigger. How do we make this smaller? We close it, that's what we do, and then hopefully, yeah. So if you remember, I see. If you remember in the contract lifecycle, instantiate contract is one important thing. So we might do the sequence diagram, but let's skip through that and we'll just go through the escrow and redemption scenarios. Yeah. So here we have the Cosmos blockchain. So that could be any Cosmos blockchain with the WASM VM. And so what happens? So the user sends an amount of time lock to the token contract, which then sends the tokens to the escrow contract. That creates the escrow, and then that gives a transaction hash. So very simple. And then the redemption, they send the amount they want to redeem. The escrow to the escrow contract now. The escrow contract asserts that the block's timestamp is greater than the time lock, and then the contract disperses, sends the amount to the user, and then finally the token contract sends a transaction hash or sends the amount finally to the user. I mean, these are a bit quick, but you kind of get the idea. And you can, of course, so I think instead of saying receive, this should be, I believe, this should be transfer. So if we went escrows, so if we rebuild this one, then you'll see we'll have a new sequence diagram with the update. And so there on the fly, we've actually improved. So send, that hasn't worked like we wanted it to. Escrow funds, transfer. Oh, because I didn't save. So that's a key problem, always remember to save. But if we go to here, now you're going to see transfer amount time lock. So that's a bit more related to real life. And if you eventually review the smart contracts, we should have something fairly analogous to this. So then also we have a query sequence diagram. I mean, this is like super basic, but here we have the escrow contract. So the user should be able to query the contract config and get a response, query the escrow state and get a response. And obviously you could go into much more detail, but this is just to highlight, I think really underused things when creating a project. So, okay. What did we do? We made a quick sketch of our project in Plant UML. We learned about component diagrams. We learned about sequence diagrams. It's all very boring, but like, in my view, this is, if you really want to build a good project, you should start with some form of design. All right, so actually, the next section says unit testing, but what we're going to do now is we're going to get our hands dirty and we're going to implement the some of the functions. So let's write some code, I guess. So if we navigate back to the IDE and we look at the README, and let's open the terminal again. What happened to that? So here, boom. Okay. Now we're at section 3 design. So if we go let's just kill this quickly and we go git checkout section 4. And so in section 4, so let me just, we can just do it this way actually. We just need to make sure it's the same. Git checkout. Okay, so let's just clean this repo, but hopefully if you're sort of following along at home on your own. So now when we check out section 4, we should see we come to the next time. So so now we have the escrow contract framework. So having created the diagrams, as we discussed, escrow, boom, component, we're going to want, let's look at instantiate exactly. We're going to want to create some CosmWasm smart contracts, yeah? So if I'm just going to run this once more to generate the thing, because I deleted it stupidly. So if we run this, let's just delete this, move to trash, boom. Okay, so it's all going a bit wrong. So, okay, I've just regenerated that. So having created the diagrams, now we're gonna actually implement them. So let's start with the instantiation. So if we look here, this is the instantiation function. So what should happen during instantiation is that we create the information that's needed to start using the contract. So what might that be? So I think the README has a little bit, not this README, this README has a little bit more information about what that should be. So the first thing we're going to do is we're going to define the storage of the contract, yeah? Which should be a config and then a storage containing information about the user's specific escrow. So to do that, we're going to use the Rust create CosmWasm storage plus, which, if you recall, has already been defined as a dependency, by this template, but we're going to want to use it properly. So now let's navigate to CosmWasm storage plus and have a little look what's there. So the first thing is, this is the GitHub, but you could also look at the Rust crates directly. So if we do CW storage plus, you can see all the crazy things I've Googled. Then there should also be a crate. So this crates.io, which is where all the packages are. So here's the README. And it's very much like what's held in the GitHub, but a little bit nicer coloring, if you ask me. So actually, we're going to do something very, very similar to this example. So we want to have a config and define the owner of a contract. So here, this kind of explains how to use it, but for brevity, what we're going to do is we're going to copy paste this, and we're going to put it in the smart contract. So going back to the architecture of a CosmWasm contract, as I mentioned to you, typically we have the contract file with the endpoints, not the endpoints, the entry points defined here. And then another one is to have this state.rs, and that's where we're going to save everything, not save everything, define everything to do with the storage. So that's what we're going to do. So we want something similar to this, but we have to say we're going to use the crate. So we just say we're going to use crate CosmWasm storage plus. CosmWasm storage, it's not called plus, but so the type of memory we're going to use, so going back to the very beginning when I said we have to manually define the memory, is we're going to use an item. And an item's just going to store one thing. So I think if you use some of the native CosmWasm stuff, there's singleton, but this is just storing, this struct is the only thing that it can store. Then obviously we can also have map, which could have, maps, a key to a value. But at the moment, we just want an item. So if we store that, why doesn't it like that? Create CW storage. So I believe we need to CW storage plus. So we've got that. This should be fine, but I think it might actually be plus. No, it's not. Well, actually, I know how to solve this, so I just can't remember off the top of my head. But if we go to the master, which has the finished project, and we look quickly in the state, we're going to see... so, I'm being very silly, and so I'm not defining this correctly. So actually, this is basically correct, but so you do use crate if it's something that's in the project. And then if it's one of the dependencies, you don't need to create. So sorry, I just heard. Boom, there we go. I knew that looked wrong as well. And so we don't need this yet, but we might need that in a bit. But here we have config. So we want to store in the config. What do we want to store? We want to store the owner, and we can store their address. So this is address is a normal type of, if we do use CW, CosmWasm standard, sorry. We can do, boom, done. Although I don't think we need storage. But here you see, we've created a struct config, and all that has is a field owner, which is an address. And then we're going to have create a new item. So this is like creating, so we can just like kill this. This is creating the item in memory, and this is the storage key. And so if you delve a bit more into how CosmWasm storage works, like it's going to have a key, and the item will create like this string here will be kind of how you could reference that storage. It's a little bit more complicated than that, but like that's what you need to know right now. So now what we're going to do is in instantiate, we're going to firstly, well, we don't actually have to do almost any of this. So we're going to, in instantiate, we're going to instantiate an instance of a contract with defining the contract owner. So what we will do for that is as follows. So we're going to do, we need to use create. So we're going to take the config, use create state config. So now we're going to create a new instance of the config. And this should be as follows. So we go we might not even need to do that, but let config equal info.sender. So who's going to be the owner of the contract? So we want it to be the person who creates a message. So how can we get that information? So this variable passed into the instantiate. So here we have like the message here we have 4 different things. So firstly, depth. So this is part of the storage. So we're going to use that in a minute. We'll go into that. The environment. So that's like information from the block in which it's being mined. Then here we have info, message info. If we look into that, it has 2 pieces of information. So sender and funds. So funds are if we sent a token to, or if we sent funds as part of a transaction, then we'd be able to see what they are here. But that shouldn't be the case in this transaction. I mean, maybe we want to send a blocker to ensure people don't send funds, but that's like by the by for now. And then sender, so that's the creator of the transaction. So we want, this is literally it. We want config owner to be info sender. And so that means whoever creates the transaction will be the owner of the config. So now what we need to do is we need to store the contract. So because we're pretty silly people and we don't know exactly what to do, we're going to look in this crate. And so this will just show us a bit how to use it, but we need to import this instance config, and then we can use it to do stuff. So we should do boom, boom, boom. We can do something similar to this. And so if we go here, I don't know why that's got red lines on it, but so we import them here, and then we can go config save. Here we go, depth storage. So here that's saying it's unused. So depths dot storage is the variable that allows us to access to like the fundamental storage of the contract, and then doing that dot save is how we can set that. So state.rs. So that should be fine. But maybe no. This should all be fine. I don't know why this is. So okay, I think it's because pub struct config, and this should be. So we need to make these public so that it can be accessed outside the state. Why does save not work? Yes. So and then this is why. So save needs to serialize, deserialize the data. So this is a bit above the pay grade maybe of CosmWasm 101. But all you need to know is that we need this. We need to have the serialization and deserializations for this struct in order to be able to save it properly. So if we just go back, and we don't want to think about this too much, so Serde is the package for that. And boom, boom, boom. There we go. So we're using that. And now the last thing we have to do is create a response. So you can see this is red here. And so we're just going to go, okay, response default. And so all this means is that like whatever called instantiate isn't expecting a response. And so if all this happens, then it will give some default response, which like ideally you should, give it some more interesting information. But we haven't done so in this case. So now the fun can really begin. So now we could maybe create. So, well, actually, there's 2 things to do. So how can we test it? So now we've created the instantiation, like how can we test it? So the thing to do is to create a query function. So in the interest of time, I'm not gonna spend too long on how to create the query function. I'm just gonna quickly copy and paste it from the example, but you should be able to follow it yourself. So this is another thing we have forgotten though, actually, is that we also want to have a token. So when you instantiate the contract, we also want to define what the token is, so who the owner is and the token address. So that's another thing we have forgotten. So token. So you could make that as token. And that should be message.token. So this is like, actually, that's good I made that mistake. So this is another key part. So we have this thing called the instantiate message. But currently, so as I mentioned to you, the entry points are how you go in, and then the message.rs in this kind of, this architecture of smart contract is how we how do I want to say, like this is how we define the payloads of the messages, the APIs. So the instantiate message, all it needs is the pub token.string. So and then this is like this is going to show us another complexity. So the instantiate message, which is passed here in the instantiation, is defined here, and it has a field token which takes a string. So, but as you may have clocked, that in the config, the thing we want to store is an address. So how do we ensure that that address, and you can already see this is red here, so we need to ensure that the string conforms to the encoding of of an address which has a specific format in CosmWasm. So that's not too difficult. We go deps API dot address validate. Here we go, which did actually come up nicely for me earlier. But all this does is it takes a string. Oh yeah, I think so. This is we won't go into this too much, but basically we need to pass it like this. And so now what it does is it takes the string we define in the instantiate message, and then it validates it, and it throws an error. So the difference between unwrap, which you've seen a number of times, and this is it means if this has a problem, then it's going to immediately just throw the contract error, and there'll be some error, right? So if it fails to validate the string. So if we look at the token, this will be whatever it is, only if it's validated correctly. If not, it will throw an error. So, okay, so now we've done that, we want to test this function. And one way the way we're going to test this is we're just going to instantiate a contract, and then we're going to implement the query function, and we're just going to query the config, and therefore, thus, fulfilling one of the use cases of the query that we defined in the plant UML, and also, testing our contract, which is a very good thing to do. So because this is meant to be an hour, we're going to just quickly do a copy pasta. So if we go to source, and so the way, if we look in the if we look in contract, then you're going to see we're going to create this query message config. So we're going to just quickly copy and paste this. Then we're going to define the query message. So if we go in here, we're just going to do this. So what this does is, so depending on the defined, so we'll just delete this one quickly. Obviously none of this exists yet. So we need, first thing we need to do is define the query message. So, and we're just going to define one here, and it's going to be config. And yeah, we'll just kill this thing because it's actually kind of annoying. So now we've got two binary. So what this does is it takes a message, encodes it to binary, and then it encodes this function into binary, and it'll return the standard result in binary. So the result of query config, which is a function that we still need to define. But the first thing is we'll just so to binary is just a function that that is from the CosmWasm standard library, and then this function here, query config, is something that we need to define. So what we'll do is usually I would put it in, or actually I'm not even going to do that. We're going to just create a new file, and we'll call it query.rs. And so personally, not obligatory, I just prefer to have all my queries in one file, so we just define it in the library, so that's included in this contract. And then the first thing we're gonna do is we'll just copy and paste it from here, but we'll also just briefly discuss what it does. So so here you see all the CosmWasm standard stuff that we're importing, so address, memory, errors, results. Then we have these config and escrow responses, so that's what's going to be returned. And then also the state, because we're going to need to load from memory the config in order for us to be able to return it. So if we just quickly, for brevity, copy paste that here, So there's a number of things missing. So there's a number of things we seemingly don't need yet. So we'll just remove those. The escrow being one as well. So okay, so now we need to define the config response, and we'll just do that in the message. So this is the interface thing, and you could use this query responses, which will auto-generate them for you, but I don't know, I'm not. We shan't use that today. We'll just define our own query message, and that will be the config response, sorry, and that will return to us something. Boom, boom, boom. And now, so we're going to just need, as in state, we're going to need these serializing and deserializing and JSON schema. Oh yeah, so that it returns a JSON payload, we also need to do that. So let's just steal that from here. So I'm glossing over a few things that you need, but in your own time you can find that out, because the important thing that we're going to do, so we still need to, so now we need to import from the create message, no, the create queries. So use create query, and we're going to import query config. And then that should, oh, and deps is just, we need to use that. So deps is access. So there's two kind of deps. So I can't remember, I think it's dependency or something like that. But there is. So if we look at this, this is a core CosmWasm standard thing. So there's deps, and then there's deps mute. And what, lo and behold, what do you think the difference is? This deps is the read-only version, and deps mute is the mutable version. So if we go back to the contract, you're going to see in the instantiation, and if I open this, and the execution functions, we have the mute version, and then the queries, which are read-only, we only have the normal deps. So, okay, what have we just done? We've created the instantiate function, so that creates a new contract instance, and in that we create the config. So the config defines the owner and the token. So the token being defined in the instantiate message, and the owner being the sender of the transaction. We then store that, and then we return a response. And then in order to test it, or you could test it other ways, but we just defined a query function, and then we're going to query that function to ensure that, what we put in is what we get out. So we're just going to delete this because I don't need it, move to trash. Okay, so I think that should be everything done. So now we're going to create a new file called unit test.rs. And in that, we're going to define a unit test. But again, for slight brevity, we're just going to copy and paste some of this. And then we're going to discuss it very briefly, and you'll have seen how to make a unit test. So the first thing we need to do is we need to do pub mod unit test, and then I believe if we just go back here and we look in how this lab, we need to give it this flag so that it knows it's tests. Let's just call it unit test so that it's the same as in the tutorial. My bad. Boom. Boom. Unit test. Okay, look, everyone's happy. So, what is happening here? So obviously that was, or like not obviously, but as discussed, we set up a load of stuff. We created the state. We created a query function. We instantiated the contract, and now we want to test that it works. So for those who've never seen Rust before, so we create the test file, so that can be anywhere, but we're using it in this part of the contract. So we define it in live.rs, and then we create a test function. So we put this little tag of test around it, and then in this IDE you can run the test from here, but you can just ignore that, and and we create a test name. So this, we're testing the instantiation. So what do? We're gonna from the CosmWasm testing library, we're gonna take mock dependencies, and so that creates a mock version of the dependencies, which is where all the storage is kept. So like you can see in this contract here, you know, here it's going to create a mock version of the deps. So wait, I think I need to save this. And then we're going to create an instantiate message. So, you know, we defined in messages.rs an instantiation message. And then where we define the token name, and remember the sender is the owner, right? So we're going to create the mock message info, and then using that we're going to call the instantiate. We're going to call the instantiate function, which is this function here, and we're going to see what happens, and then we're going to call the query and see if it returns to us the correct state. So here you go. So here we instantiate the contract, and then here we query the contract. And so we unwrap the response from the binary, or we decode it from the binary, and then we unwrap the result. And then last but not least, we check the actual. So we could maybe, like, better practice is to call this like actual config. And this as well. And then you could call this expected config or whatever, but here we have the right type of config response, and these should match. And so if we said, oh, we actually, you know, just for thing or token hello, let's call it token hello. So now we want to run this test. So we could obviously run it here, but that's like boring. So we're going to use cargo. And so to run the test, we're going to go run cargo test. Oh, it's because we're in the wrong directory. So cd CosmWasm, and we go cargo test. And now you see it compiles a load of stuff, and it's going to run the tests eventually. So I'll make this a bit bigger. Oh, and it's failed. Why has it failed? So left the actual, we got owner and token, and then the response. Well, no, this is the expected was token hello. Well, obviously, if we give it token, then it's going to return token correctly. So this is obviously wrong, but just to exemplify that that we are actually testing something and it didn't just work and do nothing. So here you go. Let me run that again. Just it pops to the bottom. Here you're going to see that the test results are okay. Look, here you go. So also it's giving us a nice warning that in helpers this is useless here. So just give an underscore. So that's the other nice thing. Well, it's not useless, then, is it? So we'll just ignore that for the time being. But here you see that, yeah. So the good thing about Rust is it tells you lots of nice things which are helpful. Okay, so what I'm going to do now is so if we go back to the README, you're going to remember that it told us to do the escrow state as well. So this should be the escrow state should store a user address, a map. This should probably be a map of the user address that holds the amount escrowed and the time of escrow. So I would say we don't need to test that right now because we haven't got the functions, but in the state you should create a map. So using this function, map, and following the things, you should do something very similar to the config. So pause the tape and, you know, try and implement that yourself. And then we'll meet you at the next section when I've done everything and we can maybe go through the integration tests. So pause. So seems that this is so hopefully you're signing back on and you're now seeing me resetting everything. So git reset --hard, git remove. No, let's just remove this thing, blah 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 CosmWasm. Okay. Git checkout section 5. So okay. Now we're at section 5, and let's go to the README. Oh, well, actually, let's not do that. Let's close all this def. Let's go back to the slides and just go over. So we did unit testing. What happened? So we created data structures for the escrow config and hopefully the state. And then hopefully we did this together. We instantiated the escrow contract and querying the state of an escrow or the config. So the next thing, we need to do integration testing and also implement some functions. So let's get started with that. Returning to the IDE, go back to the README, and we'll see. Okay, so we need to actually check out section 6. Let's just go straight to section 6. So unit testing, integration testing. So you did the unit testing. Yes. So here's a description a bit. If we hadn't have done it together, how to do the unit test, and then last but not least, integration testing. So, we've successfully created the unit tests, and now, as I described to you, we're going to do some integration testing, which will require, because we have 2 contracts now, the CW20 token, we can't just make a unit test. Rather, we need to make a mock blockchain environment and create an integration test. And so to do that, we use a CW multi-test, which I touched upon already. If we just go, let's go have a little look at it. So here's the Rust crate as well. There's also, I think, a crates.io, but in your own time you can read all about it. But returning to the IDE, we're going to create the functions, escrow and redeem, and then we're going to use CW multi-test to create the integration tests. So let's have a look. What have we done so far? So here we have, so as we described previously, we got the 2 config and the escrow queries, which we sort of haven't used, but now we're going to create the execute functions. So the first one is going to be escrow. So we're going to create 2. So we've already defined the execute messages, which is good. And so this just takes an amount and the time, and then the redeem will take an amount. But we'll go through escrow together, and then we'll then the rest can be on your own. So we need to do much like this. We need to match message, and so yeah. Oh my god! So this is the beauty of so execute message. So this should just be escrow, boom, and this should be time, I think. And let's just, so this unimplemented function is underrated because Rust will really complain if you have these matches that have unimplemented endpoints. So if you can use this, so yeah, we need this, yeah, I think. Oh, we don't need that. Somewhere it's failing here. Why is it failing here? Execute message. Because we don't have this. So let's just remove this quickly. Why is the Rust analyzer failing? It's not. Okay. So we've got we're just going to implement this first. Escrow, amount time, and create well, I prefer to call this execute. But we're going to create a new file, execute.rs, and in that we're going to define the functions, right? So going back to CosmWasm 101, and we're going to go to source, and we're going to go to execute. And honestly, we're just going to copy paste this just for brevity, because the important thing is how to do the unit testing. So why did this fail? I don't think it's actually failing. So, okay, look, here we go. So execute escrow. So if we look in contract, so there should be execute escrow. escrow, which we need to import, of course, and that should be found in use create execute escrow. Hooray! I think it's dum bum bum bum. And what does execute escrow take? Because we need to we got rid of this. Okay, I see. So we can just, so I deleted, here we go, boom, execute. So now if we look at the different files, so contract, execute escrow, and it takes what? It takes deps mute, it takes the environment, it takes the message, it doesn't take the message input, apparently not. But we do need this. So, so it takes a user. Boom. So, all right, what do we need? We need to first, we need to look at the message. No. So first we need to look at the message. So let's go to message.rs and we see amount time. But this function takes user token amount time. So what the hell does that mean? So, yes. That is because I haven't done this correctly. So the way this should work is that this will not. So that is right. So that's the step that I've forgotten, sorry, is that the way the escrow will work is we will send the CW20 directly to this function, which will have a fallback hook, which will function through receive. So there's a lot to do in order to get that done. So we're just going to copy these functions here, and then in your own time you'll be able to investigate them. So we're going to just remove redeem, and then this should, and then this should, we should be able to get this up and running quickly. Or in fact, what we're going to do is we're just going to go through it line by line. So if we just kill this and we go back to the terminal, we go git checkout section master. So we're just gonna completely ignore that, and we're just gonna go git checkout master. So we're just gonna discuss this because otherwise this presentation is getting awfully long. So here we have the contract. So just before I decided to change tact, we were in the execute function, we're adding two functions. So now we have, when you call execute, you can have receive or you can have redeem. And the way receive will work is that it takes a CW20 receive message, which is a type of message, or which is a message delivered from a CW20 message, and then we'll call this message here, and then we also have redeem, which a user will call directly. So if you cast your mind back to the diagram, this will all make sense if we look at the escrow sequence diagram, because when we send funds, we don't send them to the escrow contract, rather we send them directly to the token contract, and then that will call the receive function, which will then create the escrow, send a transaction hash, whatever, right? So that is what we're doing. So apologies for being slightly confusing. Now, if we look through the message.rs, where all the messages are defined, you're going to see there is only receive and redeem. So redeem has no information because we've made the executive decision that redeem will redeem all the funds, but let's just focus on escrow. So I will call CW20 receive message, which as you see here is from the CW20 package. And we've also had to import into our cargo.toml the CW20 tokens. So just don't forget this part, or the CW20 token creates. And then so that we can use them here. And so then we have the CW20 receive message, which is then going to call this hook. So now let's look at the contract. And if we look at execute, we see there's receive, and then which calls receive CW20, which is defined here, which further then calls escrow, which finally, which calls the hook message escrow, and finally will execute the escrow. Yeah. So just in case people weren't following. So if we look at execute escrow, what does it do? It receives the user's address, the token address, and how does it receive them? So we'll just put these side by side for the moment. So CW20 message.sender is, because as we mentioned in message.info it has the sender, it's the sender of the transaction, the message before. So in this case, that will be the token. So info.sender will be the CW20 token. So here you see for the token we use info.sender. Then for this, for the like original, the owner of the things, we use CW20 message.sender, which is like the sender of the previous transaction, and then also it contains the amount in CW20 message. So if we just look at this message type, it has sender, amount, and then another message, which is the message we used to decide that it was an escrow. Because if you see here, CW20 message.message, if it should match to this escrow function. Okay, so now let's go to execute escrow. What do we do there? Well, we load the config, we check that the config, the token held in the config, well, we check that if it is not the same, then we throw an error. Otherwise, otherwise, if they are the same, we continue. Then, if so, hopefully you managed to do on your own, load the escrow state. So let's just take a quick look at that. Then we've got the escrow state, which is a map of an address to an escrow, which also has the address, the amount, and the time. So the time being the delta period. So when we execute, we go, okay, does the user already have an escrow? If so, we throw an error because there's an existing escrow. So you, like in this, there's no, that you just can escrow stuff, you can't add more. And if not, then we continue and then we create a new escrow. So escrow, we add the user, so passed there, the amount, which is passed here, and then the time, which is the current block time plus the time delta. So that could maybe have a slightly better name, but the end time is this plus this time. So another check we might want to make is that this isn't 0, because then you could, well, maybe it doesn't matter for this contract, but then you could take the funds out immediately, or that it's not too far in the future, but you know, that's maybe outside of the scope. Okay. And then what do? We save that escrow in here. Okay. And so we won't go through redeem. Rather, the next task would be to create the integration test. So let's have a look. So much like the unit tests, where we created a separate file, we're also going to create a separate file called integration tests, and not forget to add it to our library and give it the test tags. So this test, what we're going to do is we use CW multitest to create a fake blockchain. So I'm just going to go through the key things you need to do in order to do that, right? So you need to, one, import CW multitest and the app, which becomes the is like the fake blockchain, and then these contract and contract wrappers, and then the executors, which like allows us to do a state transition. So the first thing you have to do is like just create this empty function, but you need to create instances of the contract and pass to it the execute, instantiate, and query functions of said contract. So we do that for both the escrow contract and the CW20 contract, but the functions for execute, instantiate, and query, they are in the CW20 base repository, whereas these ones here, execute, you might see that we're just importing them locally from this file here. So that allows us to call these directly, yeah? If that makes any sense to people. Then we're going to, so having done that, you're pretty much, as I say, good to go. So we're first going to create 3 addresses and just define them of the owner, Alice and Bob. So then we create the router here, and the router is the fake blockchain, basically. And then, as we discussed previously, we upload the contracts. So we're using these contracts here. We've kind of got like the compiled contract, and so we just store that in the router. And then we're going to get 2 IDs, which I think are 1 and 2, but it doesn't matter so much. And then we're going to instantiate the contracts, which, if you go back and listen to the start of this presentation, is part of the contract lifecycle. So first we're going to do USDC, or we call it USDC, it seems apt now, instantiate, and we're going to give Alice and Bob 1,000 tokens, although we're assuming there's no decimal places here, even though we said 9. So this is a little bit wrong, so we've got a very small amount of this token, but it doesn't matter so much for this. Then we're going to instantiate the escrow contract using the instantiate message, which, in the unit test we tested as well. So it's the very same message. Look here, boom, boom, boom. It's here, boom, boom, boom. Except now we're going to use the actual USDC, the address of the USDC contract, which we instantiated, just before. So then, much like the integration test, we're just going to query the config, and we're going to make sure that the addresses are correct, right? So here we query, so we need to know the escrow contract's address, and we're going to query the config. So the payload is just this query message, and we're going to assert that the owner is the owner and the token is USDC. And so these should pass. And then the next step is to escrow funds into the contract. So we create a CW20 execute message. So we're now talking with the CW20 token directly. So we create this message with the contract. So that's the contract that the CW20 will forward the tokens to, the amount, and then also the message that will be executed afterwards. So if you recall, in execute, in receive, we have this match here. So if we don't get CW20 hook message escrow, it will throw an error. So if we look in the integration test, we have this here. So if we change this to a message that I don't know, could be anything, but we won't do it now. But if we change this, then it wouldn't work. So here we execute the contract, and we just take the response and assert that this event that's been emitted. So that's another thing which we haven't really talked about. But you see here, when we define the response of an execute message, we give an attribute with an action escrow. So then in the integration test, we see that escrow event was emitted. And then, so hopefully that means a successful contract would be, a successful escrow has been processed. Now, we just test that a duplicated escrow should fail. Why should that fail? Well, if you recall, in execute escrow, if there's one there already, then this error should be called. So, I mean, we could check the error, but we don't check the error here. We just check that an error has been called. So the next question is, okay, how can we actually check that the escrow has been performed? Well, we could check the token balance of the escrow contract, because that should have been incremented, and that is what we do here. So we do a query to the USDC address with query message balance and the escrow contract address, and that returns to us 100, which is the amount that was escrowed here. And then last but not least, you can see as we run through this and we withdraw and we check the balances at the end. So that should be somewhat self-explanatory for everyone, but just for fun, let's run the integration test. So if we go ls cd CosmWasm and cargo test, well, you should see that all the tests run successfully. So you can see all the tests that are run, unit test, integration test. So now let's try and make the integration test fail. So move the block time. So we said that it needed to be, if you remember, we said we needed deposited with a time of 10 seconds. So after 20 seconds, you should be able to withdraw it. So if we change this to 9, then I think this redemption will fail. So let's run the cargo test. And you'll see, so panicked out, unwrap error. So we haven't really, because we're unwrapping and we're expecting a proper result, not an error. This fails, not the assertion. But you get the idea that we've managed to make this fail. So putting this back to 20 and running again, this should all run. But yeah, so okay. This is like I'm not sure how useful it's been. Maybe a bit too much of a whistle-stop tour in an hour, but hopefully by following some of the descriptions and also following the examples in the code or in the repo. So probably it's best to make your own repo and then use this as an example. You can see how to go from 0 to some form of CosmWasm contract. So right, so what did we do? We added the functionality to escrow and redeem a CW20 token, and then we built an integration test for all the user functionality. So thank you very much for listening. So I'm just going to go over one more time the whole thing that we did, just so that people have a better idea. So we set up the development environment, then we created a CosmWasm contract, an empty one with nothing in it. Then we designed some stuff which which we then implemented. So what did we do? We said we're going to have an escrow and redemption function and query, so we could query the two parts of the state which we had to define ourselves, which were the config and the storage. And following that, we did a unit test just for the instantiation and the query functions. And then very lastly, we did integration testing once we'd implemented the escrow and redeem functions, and we escrowed a CW20 token into the escrow contract and went through a number of scenarios. So again, thank you for listening. Please feel free to send us messages if you have questions. Obviously, maybe you could open issues in the GitHub, and I hope this has been a fairly good 101 into building your own CosmWasm contract.